today, in my opinion, the most important topics, which are about how we control the quality of documentation, of what people write about the software when they write software. And then finally, we're going to talk about how we ensure the discipline of a software development in the project, how we can control people, because people write software, so just controlling the software is not enough. We preferably have to control the people who write it in order to make them or enforce them or force them, choose the right word. But we need to find a way how to actually make them make code better and write the code we expect to write. That's going to be the final lecture. We will get there after we discuss the documentation and the methods of keeping the documentation under control. So most projects, I'm getting into documentation now. So most projects are they are on GitHub. Either you're developing open source or you're making proprietary software, then you still, in most cases, maybe there are exceptions. People use GitLab, people use some other systems, maybe Bitbucket, I don't know whether it's still alive or not. But according to many, many public information and the marketing research and stuff like that, people say that GitHub is the primary dominating platform for open source code, and not only for open source, but for all full code. So if you decide tomorrow which platform to choose for your project, my recommendation is to go for GitHub, whether it's public or proprietary repository. It may be quite expensive if it's a private team and you are not doing open source, because they charge per seat, so they charge for each. This is probably the information I got probably like 1 year ago, because I don't use it for proprietary projects. Most of my stuff or everything I do is open source, which I also recommend you to do. I'm a big fan of open source, and I believe that open source is the way to develop software, no matter whether you work for a company, you do it for money or for free. Still, I suggest to do most of the code in open source, maybe with some specific exceptions when you really need to hide something, but that shouldn't be quite frequently. It should be rarely. So GitHub is the place, and in GitHub, how do we document our projects? There's number one place is the README files. There are other places, of course, like wiki pages or maybe their documentation pages inside the repository. But my opinion is that a software project has to have a single documentation place. It's just one README file. Nothing aside the README file. It could be a large file, could be a very long document with many lines and with many sections, but it has to be just one single document. You put everything in the README file. You start from the description of what the project is for. We will discuss now how to structure the README file really briefly, and then you continue, but you keep everything in one file. It may be a matter of taste. So people say that's pretty subjective, and we still love wiki pages. And I know teams, I actually participate in a number of teams which actually use wiki pages, but I don't think it's right. I don't think it's good. Why? For a number of reasons. First, it's quite annoying for a reader to understand how you structure your documentation. You may know how you organize your wiki pages. You may know how you organize your documentation pages, how you put them into right directories, and how you label the files and how you navigate between the files. But for me, as a reader, as somebody who joins your project, it's not really interesting to learn that. I'm not really interested to do that. And if I don't understand it right from the beginning, I'm probably going to ignore your documentation, and then I'll jump into the code. And if I don't understand the code, then that's it. I'm not interested. I lose my motivation to contribute to your project. If I find, the README file is something which I cannot ignore. It's the number. It's the only place which I see first when I look into your project. I just see the README file, and of course I'm gonna scroll down. And if it's super long, I'm gonna still scroll and scroll, but I'll find everything there. I'll see everything there. So wiki pages. That's the reason number one why I don't recommend to use wiki pages, because it's hard to navigate. It's hard to understand what's what, and even though if you structure it well. Second, the wiki pages in GitHub, they're not connected with the changes you make in the source code. So you edit the code, you change something there, you make your commits, you make pull requests, but the wiki pages, they stay detached from that flow of changes. I'm not sure right now, so maybe GitHub is already made it possible to actually keep the wiki content inside the repository. So when I change the wiki content, it immediately changes some file which stays in the repository. But the last time I used wiki pages, it wasn't the case. So wiki stays somewhere in the database on GitHub. So GitHub has some database, internal database, which we don't have access to. In this internal database, they keep the wiki pages. When you edit the page, then the changes go there, but they don't go to your Git history. It doesn't go to your history of changes. It means that eventually, it means that it's hard to synchronize that. So for example, when somebody is changing the source code and they submit the pull request to my repository, and this change actually affects the other places, affects the public API of the product. So if the change that is coming from somebody is actually affecting not only the code but also the documentation, which happens very often, then it's easy for me to request the author of this pull request to make the changes to README file as well. And this change will go together in the same pull request. Whether that person updates the wiki page, I don't know. Actually, the access even may be not granted. Maybe the person doesn't have the ability to do that. So how do I request some public contributor to do all together in one solid atomic piece of change if the access to wiki pages may be not granted, or may be granted, but if they're granted, then the person will go to wiki pages, make the changes, and then submit the pull request. What if I reject the pull request? What do I do with the changes on the wiki pages? They're already done. So I need to go back, remember to go back, revert them on the wiki pages, and then reject the pull request. So that's kind of a we lose the synchronousness between these two places of information, the wiki pages and the code. It's better to keep everything under one control, under Git history control. That's wiki pages. The second place for the documentation which you can go for is maybe separate documents. Maybe you can keep it in, I don't know, in Google Docs, for example, which is also very often people do. I've seen projects done really professionally by professional engineers, but they keep the documentation in Google Docs. And that's, again, quite confusing for me. Well, first of all, Google Docs is not for documentation about code. Google Docs, Microsoft Word, all those stuff, they're really good for maybe for business documents, maybe for writing a novel, maybe for writing a poem, maybe for writing an essay for your diploma work. But even in this case, I would stay away from Google Docs, from any kind of this kind of format where this called what you see is what you get. This format, when you type everything and you immediately see when you immediately get the result on the screen, you see what you type in. So that kind of systems, which are called what you see is what you get, I think they're not for engineers. They're not for programmers. For programmers, we use formats like Markdown, like LaTeX, like maybe rich text, something like that. Something where you type the plain text and then some system will render it to make it look nice in a PDF format and whatever. So expecting the system, expecting the editor to immediately show you how it looks and let you edit it the way it looks, it's kind of, I think, not really professional. So that's another reason for the against the wiki pages, and of course against the Google Docs documentation. But back to the problem of synchronization. Again, if you write something in the Google Docs and at the same time you have a different content on your Git story, on your Git history, then how do you make these two sources of information match? You do not. You basically abandon either one of them. So you either ignore the information which stays on the Google Docs, or you ignore the README and the documentation with the code. Usually it happens why people go for Google Docs because they don't know how to write documentation professionally in the formats which are plain text based. Like I told you, where you can type, but you don't see how it's going to look. And for people, it's kind of uncomfortable for some people. We call them immature engineers. So they don't know how to do it. You need to train yourself to do that. That's my point. So don't expect the system to render, to show you everything immediately nice on the screen. That's immature approach. Go for plain text, editing in plain text, then click the render, or better not click the render, but let the system render it for you. And then you see the beautiful document which you see. So we keep documentation in Git history. That's my point. We keep everything in Git history. If anybody suggests you to go outside of Git history and create documentation, diagrams as well, to make it outside, then you question that situation a few times before you do that. Even for diagrams, so let me emphasize that. There are tools which will allow you to also use the plain text and then get the diagrams from the plain text. Like, for example, PlantUML, or this dot language, where you just can make the diagram using very simple language with the when you type the plain text and then you get the diagram. Well, or you can use LaTeX. In LaTeX you have this PGF TIX system, maybe you've heard about it, where you can render. You can do anything there. It takes skills, definitely. You cannot do anything just tomorrow when you start using it. But if you learn it, then it's going to be it's not going to be simple for you. So TIX is not as simple as Dot, for example, or PlantUML, but it's also in the same paradigm. It's a plain text which stays in the Git history. I can see who changed what. I can see who moved that box from the left to the right, because it's going to be tracked down in the Git history. I cannot see that in Google Docs. I can see probably that they changed, but I don't think there is possible in Google Docs to see to track the changes for the pictures. They only let you see that the picture was changed by somebody, but what exactly changed in the picture, you cannot see that. It's my summary, so try to keep the documentation inside one piece of file. It's a README file. But not only that, there is another place for documentation, the second one, which we discuss as well after, which you probably understand. It is also inside Git history. It's in code documentation. So while you write the code, you may put the pieces of documentation, quite large pieces, inside your code, which will help you to comment, to explain what you do. So let me share the screen and we will discuss README files first. We call it README MD. So how I would suggest you to write such a file. In the beginning, of course, the good idea is to put the logo. If you don't have the logo, if your project doesn't have a logo, then probably we're not going to love your project, because we see that you didn't even invest 5 minutes of your time to just invent some nice, beautiful, interesting logo. So if you do something more than just 5 files, then I suggest to do the logo. Then we do the badges. We put some badges. Some people make fun of those badges. They think they're not important, but I think they are. They're just kind of a part of a culture. You know what I'm talking about. These badges, which, for example, CI badge. There could be code coverage badge. There could be the license badge. There could be the badge for example, if you do the Java, the Maven Central badge. So these are the pieces of information. They're not just for fun. They just immediately, quickly, visually give your reader, give your user an information quickly of the key information which they're probably looking for. For example, I jump into your repository. I don't have, 15 minutes to find out exactly what is the latest version you released, because it could be in the releases part of the repository, maybe it could be somewhere else. I don't know. If I see this badge, I immediately understand where to look for in the Maven Central and what's the latest version you have there. So, for example, if you go to, I don't know, for example, my repository, one of mine. Let's go for Cactus. It's one of the frameworks I showed you before. So this is Cactus. It's pretty well, it has some badges. So look, this is the badge from Maven Central. So it says the version is 0.54.0. So I don't need to look into releases and find out what's the latest version, which may be not there by mistake. I just know that if I click there, I go to Maven Central and I find the latest jar and I can download it just from here. It's this license, some information, there should be some download button. Yeah, it's there. So I can click download and it will be downloaded. So this is just a courtesy for your users. You just show them what they're looking for, the badges. Some people say there are too many, but I don't think there are too many. I suggest to put them in just one line. So if you see how they're organized here in the file, then they just go one after another without a space. So it's just one. Each badge goes on the line, separate line, and when they render, they just rendered. The line flows to the next, and so on. I also put these badges, which I designed myself. They're just for fun. These are just basically for fun. It's kind of a promotion. I do this for IntelliJ IDEA because I love them. They make a really good product. I use this product, so it's like a promotion because this code was written mostly on IntelliJ IDEA. This is the promotion of my own tool. This is of my principles. So it's like a marketing, but it's still useful, I think. So people get in there, they may click. You can just immediately give people some interesting information. That's, for example, total lines of code. 64,000 lines of code. It's pretty interesting information. We'll discuss it later today as well, whether you pay attention to this or not. This one as well, we're going to discuss hits of code. So I recommend to put badges. If your repository is well organized, then you're going to have more than just one badge. You're going to have a number of them. Because, for example, coverage. It shows me there's 90% coverage. It's not only giving me the information that there's coverage 90%, it tells me that people really care about publishing this data, about making that available for the users. So I can click this badge and I go to the dashboard, which shows me the coverage report for this repository. And I can, that's a code cov, which gives me quite useful information. I can go deeper. It's pretty nice way of reporting the coverage information. So you can go to any place. We discussed that before. So it's code coverage. Now you can jump in and see exactly what is the report there. So of course we can just ignore it on the repository and just say somewhere in the text, if you're interested in the coverage, then click there. But this is faster and it's more attractive to the user. So when you do your projects for this course, then think about this. Every time, I can tell you, last year I was also teaching in Innopolis, and the projects were submitted for review, and I had to decide which project is of higher quality, which project is of lower quality in terms of architecture. And I can tell you, honestly, it's always a matter of personal opinion. It's always quite subjective opinion. So when I look in the repository and I see absolutely zero badges in there, then my opinion is that, maybe something is not, as perfect as, let me mute you guys. So it is not as, the people who develop that don't care as much as they could about it. They just do it for, they just do it without personal attachment to what they do. So the badges, that's it for the badges. After that, my suggestion is to give one paragraph where you say exactly what is it about. And in this set about, you say, you better do it in this way. You say, there is a problem, nobody solves it, we do, we solve it. Should be the structure. I think it's just a standard way of pitching somebody. You say there is a problem, then you say nobody knows how to do it, and then you solve it. Maybe you can even say in the end that maybe we're better, or we prove it, or it's proved, something like this. But this is. Sorry, there's somebody speaking. Sorry, guys. Okay, so this is basically the more or less standard way of pitching anybody an idea. You first emphasize the problem. If you don't say anything about the problem, then we're not interested. We're not interested to go to read your documentation. We're not, because if it's yet another software, yet another framework, it's boring. We don't know whether you understand the reality around you, whether you pay attention to what other people are doing. We're not gonna get interested. So first you're gonna say there are many Java frameworks which do this and that. However, none of them gives us the way to do the reactive programming, whatever, of HTTP 3. So we do it, we provide HTTP 3 in a reactive way. And we solve it by making it in Java, so you just take it and use it. So after this, after you pitch it, after this one paragraph, I suggest to go for how to use. So you need to give me an instruction of how do I use it immediately. I don't want to read a number of pages before I understand how to use it. So how to use should be as fast as possible. So like here, I'm not sure it's going to be, yeah, you see, so we give the motivation. First we say, okay, of course it's attention. So we say it's quite early, blah, blah, blah. It's early draft, so don't expect the changes. And then we say, this is a collection of primitives, and then the motivation. So we are not happy about something. So we explicitly explain the problem. So we say something is wrong. We're not happy about this, and this. They're not doing something right. They're wrong. The world is in trouble. So we suggest some design principles and how to use the library, blah, blah, blah. So how to use it, you go for Maven, Gradle, you take it like this, and then immediately the example, like how to read the text from the file. So as soon as possible, we're trying to jump into the first piece of code, which you can copy to your IDE, to your editor, and just run. The sooner your user can do that, the better for you, because they're going to use your product. So, first of all, one paragraph, which, like I said, problem, solution, how we do it, and then how to use. How to use ideally should be the code, the piece of code snippet. As soon as they know how to use it, they will try, almost all people will just try your code first, and with a simple snippet. So this snippet absolutely has to work. It's not allowed to make mistakes there, because if they try it and it doesn't work, that's it, end of story. They're just gonna quit. They're not gonna use it. So people, I read it somewhere that people have GitHub people programmers who are on GitHub, maybe you can confirm that, they have very short attention span. So when they find your repository, they just look at it for like 10 seconds, something like that. It's not even minutes, or it's just seconds. So they look for a few seconds. If they don't see it as something interesting, they just close the window, because there are millions of repositories on GitHub. There are many people who write code, with little understanding of how to write code. And there are tons of these abandoned repositories, tons of these products which are not supported or just don't make any sense. So people will look at this code snippet, and of course, I think we discussed that many times. People are gonna look at two factors besides your snippet, whether it works or not. They're gonna look at how many stars you have and how many what is the. I think that's the primary reason. It's the second one. They're gonna look at the recent commit date. So if there are not enough stars, maybe stars plus forks, but usually they come together. So forks are just like some smaller number. The stars are going to be usually bigger and forks smaller. And then you're going to look at the recent commit date. So when was the last change done to the repository? If it was 2 years ago, then of course we understand that and that's it. This repository is done and nobody is interested in it anymore. So if you want to keep your code, attractive to users, then of course pay attention to how many stars you have and how often you update the repository. Don't abandon it. So regularly make some changes. Even if your code is already done and you think that your product is already finished and you expect people to use it, still regularly update it. Check what's going on there and make the changes, some changes, maybe increase some dependencies like we discussed before, increase the versions of your dependencies and so on. So make the product alive. Okay, after that, the question is, what do you do? What do you say after that? Well, it depends on the repository, depends on the product. So here, for example, it's quite simple, even though the library is quite big. I showed you there's 60,000 lines of code. It's a pretty large piece of code. But the documentation is not really big. We just show the code. It's a library, so we show you can do this, you can do that. We just explain to the user what they can do. This is the best way to write the documentation in the software project, is to show the code. Instead of writing text, you probably know that, just show us working examples. Just show you can do this or that because for example, me, I don't even read this stuff. Usually, I just ignore the text. Like visually, my eyes don't stop here. I only look at the code. Maybe that's my personal behavioral pattern, but I just look, can I do that? Is it useful for me? Something like this. All right, I scroll down, the tables. So I pay attention to the code I see. I don't read textual descriptions. Only the code. So the more code you show in the documentation, the more examples of how to use, the better will be, the easier will be for me as a user to understand what's going on, to understand your structure of the code. And of course but that's one example. So let me give you another example of another repository, also of mine, which is also we still support and develop quite actively. It's another framework. Also, you see the badges, which are different. Sometimes we don't use the same because different teams are working on that. And here we say again, this is blah, blah, blah. This is a framework. It's key benefits comparing to all others. So this is the problem. So we compare to all others. And then by the list of this, we kind of emphasize the problem. For example, we say there is not a single null in our repository, not a single public static method in the repository, even though it's quite big. So lines of code, you see the badge is not loaded. So let's try again. Maybe it will show up. So it's also pretty big. So maybe there's also, I think, more than 20,000 lines of code, that's for sure. And we don't use a single public static method. So it is kind of emphasis of the problem. So we don't say that, other frameworks, they use public static methods and it is a problem. We just, in one paragraph, we state it all together. We see there's why it's bad. So we catch the attention of the reader saying that there's something is wrong with the world and we suggest to do it differently. And then we go for contents. So here we say the contents, like in a book. I'm not a big fan of these contents lists because, I would suggest to, instead of writing contents, but that's my just personal opinion, I think that when you have to write the contents, the table of contents, then your document is too big. So your you need to try to compress your document and say less words and be more compact and more specific. But maybe sometimes it's not possible. So in this case, you can see how many sections we have. So each section explains you how to use the framework. And then we go for quick start. Again, quick start. So create this file, download something, run it like this, and should work. So that's what most people will do in order to try. And if this doesn't work, then that's it. Yeah, that's going to be the end of the story. They will just quit and they're not going to give me the star. They're not going to use it. And you know, there's something I also need to mention that important. You see, sometimes you need to explain what are the prerequisites, the dependencies of your product, what needs to be there before somebody can use your stuff. And usually it should go before quick start. So in this case, it's just Java framework. So basically there is no quick start, but still it would be great to say here in the beginning that you need Java at least. You need to, takes jar. So you need at least like Java something, some version, and then maybe a link to where to download. So here we kind of expect that the reader already knows Java. But I know a few projects I can show you which we're working on right now. Also, for example, this one, which needs tons of dependencies before you can even start it. And it says how to use it. For example, this is also like one sentence. It says what it says, and then it goes how to use. Again, like a quick start. And then it says assuming you're on Ubuntu, and then it gives you the instruction how to run it. That's okay, but look at the sections how to contribute. So before you can contribute to us, you will need this list of dependencies. So they tell you how many things you need to install, you have, before you can go. But still, even in this case, we tried to make it short. So we gave an explanation of what to install beforehand. So that's important. So maybe it's important to mention it here, like I said, before how to use, you say prerequisites. So what is required before you start blaming us? You better learn what you may miss on your computer before you do it. So that's and then after that you go for content. So here you explain, like I said, snippets, code by code, and you keep it this way. And finally, in my opinion, you should say, in the end, you should say how to contribute. So somebody will like your stuff, they will look for instructions of how they can contribute to you. I don't like repositories which write a lot of documentation about how to contribute. Some people do, and actually big repositories, they do it. Well, I can understand why they do it, because they are getting tons of pull requests from complete strangers and completely random people who, again, don't know what they're doing. So they get overloaded by these pull requests. That's why they start writing documentation how to contribute. But I think it's just wrong. They're just trying to put the problem on our shoulders instead of solving the problem by themselves. So I think the how to contribute should be short. You have to say just like in here. I mean, it's not really short, but yeah, in this project it's quite big, and this is not really good, I believe, because look at the section how to contribute. So first I need to install this and that. Then I need to install this. All right. Then I need to install that. Okay, maybe I can do it. Then I need to prepare the package. And after that, I make changes. They tell me how to make the changes, how to run the build after the changes I made. And then they tell me, before you send the pull request to us, please do the checking. So check it with this, check it with that. Run all these tools and check and check and check. After you run the unit tests and everything is good, then they have to say it here, then everything is clean, then you submit the pull request to us. It's quite detailed instructions, which I believe would be better if all of this information would be printed to pull request submitter in an automated way by the build pipeline. So it's better to configure. Well, I think in this project it is configured, so you're probably going to see a problem if you submit the pull request. So all of these steps are already built in. So I think it's not really necessary in this case. I'm going to tell these guys that it's not really necessary to do it here again, because this information must be printed to the console. So maybe it's better to, if this step fails, for example, Clang format fails the build because you didn't format the code, so it's better to print the message in the log and say, please run this command. So it's kind of interactive way for people who submit the pull request. In this case, when you print it here, then you of course have it in the build pipeline. So it's kind of double. It's two places. You have it in two places. You have it in the README file, like instructions for your for the people, like don't forget to run the test, don't forget to run unit test, don't forget to run the format check, the static analysis, and everything before you submit it to us. But then when you submit it to us, we're still gonna do all the checks, and we're gonna file the complaint to you. We're gonna tell you in the log what went wrong. So why telling beforehand? I don't know. I mean, maybe it's better to just incorporate all of these steps into the build and say just in one line, just run, just build it with one-liner, like we discussed before. It has to be just one-liner, and then this one-liner will tell you what's wrong. So, in my opinion, how to contribute should be like this. Let's scroll down. This is the takes framework. You see, it's quite big documentation, very long, many pages or everything, and then how to contribute. That's it. So this is the text I use usually in my repositories. I just say fork repository, make changes, send the pull request. We will review it. Before you send it, run this one line, which will tell you whether it's okay or not, whether the build is still clean or not. And then I say to avoid build, just use, this is my prerequisites, use Maven 3.2. So it has to be short like this, I believe. Don't make this information large. Keep it short, keep it small. In general, the smaller your documentation, the shorter, the less words you use, the better. So try always to reduce the size, to remove the information which is redundant, which is duplicated, which is maybe too verbose. Maybe you say too much. So try to say as little as possible. It's difficult, of course, it's always difficult to write short. It's always easier to write long. Because writing long, you don't care about what you write. You just write, you type, and that's it. It's just physical exercise. But when you really want to make it short, that's a separate story. You need to pay attention. You need to think how to write less, to remove the words which you don't need. It's art. So the shorter your documentation, the more complete it is, and the shorter at the same time, the better for everybody. So that's about README files. And also we wanted to talk about in-code documentation. So in this case, I don't think we need to make a break this time. I think we can make just two pieces, 2 lectures, 1 hour and a half and 1 hour and a half, and then that's it. So let's continue with the documentation. So that was about README. README long enough, but at the same time as short as possible with everything in it. Then the documentation in the code. So what do we have in the code? In the code we have code blocks or Java doc blocks or whatever blocks you call it. We can look at this, for example, this framework, and see how they document the code. src main Java. Let's say take first file. So this is the documentation block, this one, which goes before the code. Historically, people had inline documentation in most programming languages, maybe in all programming languages, people are allowed to write documentation, but there were no, until recently, I think, well, recently depends on what is recently for you, but I think 20 years ago, there was no consensus about how to write documentation for a class or for a method. And I still think that for some languages there is no consensus. For languages like maybe JavaScript, I think most people don't really care about how they document functions. They just do it the way they like. For Java language, there's more there is a standard which was invented some time ago, and people use this standard. For Rust, for example, the language which I code recently in, I think the standard is even more advanced. So they kind of they suggested even the next step after Java. So without the standard, you can just write whatever you like. You write the text like you write the text, and that's it. But the standard helps tools to take your text and make it rendered in a nice way. I think I'm telling you now the obvious things, but still pay attention, because most of the projects which I see, they don't document their code properly, and most programmers. And I work with programmers who code for 15 years, and they don't document their code properly. For example, you need to understand how the tool will take your code and render it. So when you document, don't just document, run the tool and see what's the output. Let's take a look at this. So how this tool, so we have the same framework. So this is our file, and let's see how this file is rendered by the Javadoc. Here's the link. We have really nice Javadoc IO service, which does everything for us. So let's find this takes class and see how the text which we wrote is actually rendered. So take a look. This is the documentation, and this is Java. And this is documentation, and this is the Javadoc block. So this is my text, and this is how it looks when it's rendered. You see, take, and then the dot, and then the next paragraph. So the first line will always stay at the separate paragraph. So even if you write it, even if you say here take, and then after the dot you say something, then what you say here will be moved to the next paragraph. Many people don't understand that. So you cannot, if you type the paragraph here, if you continue after the dot, then no matter what, it's going to be moved to the next paragraph. Then we start the paragraph. That's the text. This is the text, which we start with this symbol. So it's important to understand that Javadoc understands this text as HTML. Rust, for example, understands it as Markdown. Javadoc thinks it's HTML. HTML with a special syntax. Like, take a look at this. This is special syntax inside Javadoc. When you say add link, then it's going to be the link to the class inside this project. And really, it makes a link. Look, this is the link which is incorporated here. Most people don't understand it and don't use it. They just say, instead of using the link, instead of using this meta formatting, they just say via, like end user via printable response. But in this case, the link is not going to be clickable, and it's not really user friendly. Then look at the code, how it's formatted. This pre, I don't know, means that between these pre elements of HTML elements, obviously, goes the text. But look at how the text is placed here. You may ask why it stays together with the pre, and why there is a space here, and why there is no space here. So try it out yourself, and you will see that if you move this new pre to the next line and put it in the next line, the whole piece will be rendered wrongly. It will look wrong. Now it looks perfect, if you ask me. So now it's completely correctly rendered. If you change the format in here, then it's going to look differently. And look at this, for example. This is also important thing. So when I put it here, it means the @ sign. This is HTML code. It means this sign, this symbol, @. But I have to do it like this, because if I put @ then Javadoc compiler will complain about it. So we're not going to discuss exactly how it works. You can learn it yourself, but understand the principle. It is a language there. It's a language which you program. So your documentation is not just a piece of plain text. It's a text like we discussed before. It's a plain text which you write as a plain text, but the tool will render it to something more nicely and better looking, like here. So this documentation looks like a documentation. Looks like this is the text, this is the fixed font text, this is a fixed font text, and there's a links here and the link there. So it's readable piece of documentation. It's quite nice and quite, even though as much as Java can make it nice, because in Java doc it's very old format and not as nice as, for example, Rust can do it. So I can show you the Rust library, which is much nicer. This one I was working last week on, and you will see the documentation, the quality of documentation. So here's for example, the Rust code. Let's do, for example, here. So this is that's the piece of, that's the method. Actually, method it's not a method, it's a function. In Rust, they don't have really methods, they have functions. And here is the documentation, which is marked down. And look at how it is rendered. I don't have a badge for the documentation, unfortunately, but I have to find how to do it. But we go through this site instead. So that's documentation. You click in there. I'm trying to find you that method. So that's the method add. So you see how it looks. They tell you the text here. You see how they render it. That's my piece of text. Add a new vertex v1 to the such. So using Markdown, they understand this way of formatting. So they put the v1, you see, like this. And there's a code with highlighting. So it's much, I think it's nicer, more modern and more attractive. It's like a nicer way to read the code. And like I told you in the previous lecture, that Rust actually runs these pieces of code. In Java, you cannot run that. It's just text. Maybe there are tools which will allow you to run that, but I doubt it. I don't think they exist. So here is just text, so nobody validates that. If I make a mistake here, I just release it, and that's it. And people will be confused because this text is wrong. So for example, if somebody will, look, this documentation belongs to the entire package. So somebody starts making changes to the package, and they make the changes in the code somewhere, but they forget to change this piece of text. So nobody will catch that. Nobody will know that, and we will accept the pull request, and that's it. And we will unsynchronize the source code with the documentation. In Rust, it's not going to happen, because if I change this code, then the build just fails, and the documentation will not be published. So of course, Rust is quite powerful in this area. In Java, maybe you will find tools which will allow you to do that, but I doubt it, because Java is more maybe just try. Maybe you can write one, you can make one and help everybody. But so far in Java, it's a problem. It's a problem how to synchronize the documentation, in code documentation. I'm not even saying about README file, because it's even further away from the code. When you change something in the code and the README file is far away, then how do you know that that the pull request which is coming to you is actually the changes are taken into account in the README as well? You don't know that. In case of Rust, you can know that, and it's good that they allow to do that. Now my point is how much code you should put there, how much information you should put in the documentation for your method. I believe that you should put as much as possible. For example, this piece I actually edited just before this lecture to make it like a good example for you. So look, this is just a method bind, and we can go and read the documentation here. So look, this is the method bind. You don't see the code, you don't know what's inside, you don't want to see the code. Even you can click here the source, and it will jump you to the source and show you everything. But normally you don't do that. So you as a user, you just read my documentation. It explains what it does, some manipulation with the graph, just an introduction. Then you show the example, and then it is advisable, it is recommended to explain all the corner cases. So I say, if either v1 or v2 is absent, then the error will be returned. If v1 equals to v2, error will be returned, and so on and so forth. So you explain to the user what situations, what alternative use cases they are to be prepared for. Not only the main flow, because before today, I had a documentation which ended right here. Like, this is how you do it, this is the example, period. But then I was thinking maybe it's not really good to present you. Like in this case, for example, I can show you another method which is documented exactly like this. Let me show you something. Yeah, for example, this method, toXML. So you just get it, make XML graph. For example, for this code, the printout will be like this. What if there is no code in the graph? What if I don't know, what could be another situation, but what about some alternative cases? It doesn't say anything. And that makes people confusing because they don't want to know what to expect. The only way for them to check what's going on is to test it. But that's time consuming. So it's better to document it like I did with this method. Just explain all possible alternative cases which you have in the method. The more you write, the better, the more detailed here is the documentation, but not more wordy, not more verbose, not more like detailed, but in the wrong way. So when you say too many words, try to say as little as possible. Don't use English so much. It's a technical text. So say it as like don't use phrases like according to the previous paragraph, we ask you to look at this particular snippet, how it works. Make it short. Look at this or use this code. The shorter, the better. So that's my advice for the documentation. And of course, you must ensure that your documentation is rendered somewhere. Because in most projects I've seen, actually in all projects I've seen, for example, from you guys last year and from many other people who I work with, they don't, well, first of all, they don't write this documentation at all. They just don't write. And when we ask them to write, they ask me why. In most cases, they say, come on, it's annoying. I would love to code. I don't like to write documentation. My job is to write the code, and my job is to write the Java lines and Java methods. Documentation is kind of boring. But when we check the quality of our code, we use the tool, which is based on Checkstyle. And this tool is making it mandatory for a user, for a programmer, mandatory to put this Java doc documentation, I'm talking about Java now, to each method, to each attribute, to each class. And that makes people unhappy very often because they say, like I said, I don't have time for that. I'm just making a small class, a small Java class, and the size of this class is just 20 lines. So for these 20 lines, my Java documentation will take another 100 lines. And they don't do it. I think some of you who listen to me now also think the same way, and I try to convince you that's wrong. So try to enjoy it. Try to enjoy the process of writing high quality documentation. In order to enjoy it, you need to learn the format. Not only learn, but render it at least once and see how it looks for the user. When you see how it gets rendered, when you see how beautiful it is, then you start enjoying it. Then you start liking it, and then you start liking the process of writing the documentation. Until then, for you, this is just plain text with no meaning, with no end result. When you write code, you know what's going to happen with the code after it is rendered, when it is executed. When you write the documentation, you don't see the end result. You don't see what it leads to. So what it makes, what's the output. That's what the rendering is important. Try to render it. Try to see what is the final result. That was my point about documentation, because it is a problem in the industry. It's with everybody. People just don't write it. People don't make documentation, in code documentation. The best people do is then they put the so-called inline, what's the right name? in-code comments. So let me share my screen again and show what I mean. So in-code comment is something like that. So when I say, it's Java, when I write some class and again, it's something very obvious, but I need to say it. Many speakers, say about that. I don't know. Let's do this code. Doesn't mean anything, but so this is the code, and most people document it like this. Maybe even like this. So this inline documentation is completely useless. It's only useful for people who will really dig deeper into your code and try to investigate and understand, but still, it's quite annoying to have it there. For example, well, there are many reasons why. You can hear many presentations of many programmers saying that's wrong. In my world, I would completely, not would, but when we write Java code, we technically prohibit people from having that kind of comments at all. So it's not possible at all to write that. If you do it, then the style checker will just complain and will reject your changes. So what is possible is to do it here in a proper way. Then you say, for example, like this. It's a structured. It's a Java doc formatting, and you say, I don't know, a value, but it can be 0, or we return 0. Like I told you, if I say something here, then this sentence will be rendered, if I run Java doc, it will be rendered like this, as a new paragraph. So it's better to make it explicit. So the first paragraph must always finish with the dot or the question mark. So Java doc will just understand it and take what it sees until the question mark or the dot, and then start the new paragraph. And it's a good practice to start the paragraph with the P and finish with the P. Maybe this one can be omitted because in HTML, before HTML5, it was okay to have this format. And of course, you document it with return and then say a new great value. So why this is better than inline comment? Because it gets somewhere. Like I said, it will be read by the tool, and the tool will make a nice, good-looking set of HTML pages, which some people will actually enjoy reading. Nobody will enjoy reading your inline document, inline commenting like this. We blah 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 blah. Nobody will. The only information we get as readers when we see that is that the code is too complex, is that the code is too difficult to understand, that even the author of the code commented it out. Not commented out, but wrote the comment inside the code to explain something which is difficult to understand. The code must be self-explainable, self-explainable. It has to explain itself. If it doesn't, then people start making comments. And of course, if the code is long, then these comments usually do not belong to the author. They belong to people who go after the author. The author wrote the code a long time ago and disappeared because it was okay at the time of writing to understand it. Now the author is gone, we jump into the project, we see that there are problems, we don't understand what's going on, and we're trying to find out, but we as not really professional programmers, instead of decomposing the problem into smaller problems, into smaller methods, and then making them easy to understand. We start making comments in the large piece of code. That's just wrong. So if you don't understand the code, you don't write comments inside. You decompose it into smaller pieces. So my suggestion is to completely prohibit comments that go in between the lines of code. Just technically, just configure your style checker, if it's possible, to disallow that kind of lines at all inside the methods. Only this stuff is allowed, because in this stuff we present the information in a structured way, and it is not a help for a bad programmer. It's not an instrument because this is an instrument for a bad programmer. A programmer doesn't know what to do, so the programmer starts writing comments. This is an instrument for a good programmer. The programmer knows what's going on. The programmer is happy about the code. The programmer loves the code, and then the programmer writes that stuff, explaining, like, look at my beautiful method. It does this and that. I will explain you how it works. I can even give you some examples of how to use it here and make it beautiful. So you're gonna love it. So it's like a decoration. It's like a polishing of the code for people who are proud of the code they write. This is for people who hate the code they write and hate themselves for doing that. Okay. So if you don't render your documentation, you're doing something wrong. Don't leave it like this. Always configure it. And there are tools. We're lucky to have them. For example, for Java, this is a really nice tool called JavaDoc.io. It's free. You don't pay for it. You just, of course, if your project is open source, but like I told you, your project must be open source. So you just give the location of the project inside Maven Central, and it just pulls it from there and renders, and everything goes well. The same for Rust, the same for many other programming languages. Just learn how to use it, and you will be happy. You will love to see this documentation. Okay, one more thing I wanted to tell you about documentation, which is quite futuristic, I would say, which is quite not for now, but maybe for the future. Well, some people do it, but I also tried and had some good experience with that, but not on a large scale. So it is possible. It is possible to make this documentation, which we write, to make even one step further, and in this code, in this text, not only say to the user how to use the code, but actually say something for some tools which would control what's happening inside the code. So let's say in this particular very simple example, we may say, for example, we may say something like this. So this information is like a meta information about maybe like this. So this meta information may be maybe used by some additional tool which will control how users are using these methods in other places. So when it's even on the step of the compilation. So when the code is compiled, or when the code is analyzed by some tool, then they may find, for example, somewhere else in another piece of code, maybe another function, it may say, and when we're going to compile that code, then the compiler will jump in here and say, hey, violation of the constraint. Maybe it's going to be a warning, not an error, by a warning telling that something you do something wrong. So the author of this code told you not to do it, and now you are doing it. So maybe you shouldn't do it. Something like that. So it's like a next level above the code you write. And there could be even I'm trying to get to the larger point that it was always the idea of people that we can explain our thoughts about the architecture using the English, using plain English, not UML, not Java, but in just plain English. And if we explain those ideas about how the system is structured, how it is designed, then afterwards when we code, some software may check whether the text we wrote is actually compliant with the Java. Actually, the other way around, whether the Java is compliant with the text we wrote. So in the text we explain that, look, there is a constraint, but that's a really high, it's a really low level primitive constraint. It could be a much higher level constraint. For example, at the level of the class, we can say, for example, this class is, I don't know what we can say about the class, but for example, we say, I don't know, this class is supposed to be it's not even the level of the class. It's more like a system level. So we say even not even the class. We just go above that, and somewhere maybe in the README file or some special file which is on top of the system, we can say the foo is an abstract of a database, and the bar is a client of a database, and that's it. For example, that's all we're saying. So there is some abstraction of the database, and bar is a client of the database, and then we write the code which says XYZ, and then XYZ is doing this. So in this case, the analyzer will say, hey, you're not a client of the database. Why are you touching? So you kind of break the idea. This was the concept. That was the idea, the high level explanation of what the system is doing. We kind of explain the structure of our system, and then this structure is being violated by this class. So what's happening here is not exactly what was expected, and this analyzer will raise a concern and will try to stop us. And people made a lot of attempts to actually invent these so-called these kind of languages. They're called controlled natural language, CNL. I even wrote my own language, which is called, you can Google it, Recus. So this controlled natural language allows you to write the text in English, but it's not really English text. It is parsed as a normal language. So this is a token, and this is the 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 token. So they parse it on the tokens, and you cannot say, for example, foo is an abstract of, is maybe an abstract of a database. So this maybe will be highlighted as an unknown token, and there'll be an error on the parsing of the language. So for a user, it looks like a controlled natural language, but I can show you my language. Maybe you're gonna like it. So I'll show you the text in my language, how it looks. So for example, you're saying, for example, this is the text in my language. It says image is a file. Image has width as pixels, height as pixels, and format as PNG, GIF, JPEG, etc. So it looks for a user like a plain English, but actually it goes through a parser, and the parser understands it using the Backus-Naur form, which has the types and the words. All of these words which are is, has, those are the English words. Well, let me give you another example. I want to show you a bigger example. Hold on, maybe it's in my blog post. Yeah, there. So take a look. I'll show you now. Oops, sorry, no, that's not right. Incremental requirements for records. Yeah, for example, this. Department has employees. Employee has name and salary. Use C1 where employee gets raised to be determined. There should be a larger piece. Hold on. Okay, I'll show it to you next time. Maybe this one. Oh yeah, there you go. So look at this text. So this is a full example of the language which looks for a user like a normal description of what's going on in the system. For example, use case 1, where a user socializes. The user identifies himself, the user invites user accepts invitations, publishes status. So all this text here is kind of a description of how the Facebook may work, or the social network may work. It's a very simple description of a software system which allows people to communicate with each other, share updates, exchange some information, stuff like that. So there are use cases, use case 2, use case 3, use case 3, use case 4, etc., etc. This use case has an alternative flow, and so on and so forth. It's all in English, and it's a readable English. So it's a text which anybody can read and understand, an English-speaking person. But if you send this text to the processor, to the parser, to the Recurse parser, then all of that will be converted to the UML and converted to XML. It will be converted to whatever you want. It will be converted to a model which you can then use in the software to, for example, restrict your software, or maybe to generate the classes in the software, or maybe to make sure that the classes which you have actually are named this way, and you have the class user, you have a class invitation, status update, timeline. So you draw the concept, you draw the idea in the text, but then some instrument just turns this into UML, for example. And with the UML, Recurse syntax, we saw that. Recurse examples. I want to show you the UML which it draws. It makes the UML as well. Maybe I can't find it right now. Okay, maybe it's somewhere deep inside, but it can be, you can trust me, it just parses this stuff, and it can render you the UML diagram, which you can also use or analyze, give to other people, inject into your documentation, so on and so forth. And there are many systems like this. I'm absolutely not unique with this idea. There are tons of products which people, tons of languages which people invented like that, and you can invent also something like that. The language which will be parsed, you know probably how to design a language, you know how to how to make a parser, how to use how to make a tokenizer, how to turn a text into a tree of tokens. And then when you have the tree of tokens, then you deal with the structured information. So first you invent the language, invent the syntax, invent the principle of it, and then you it's like a meta programming. It's like programming on top of programming. It's a documentation which is not only that the plain text, even though it's a plain text, I mean, look at this text. It's quite rich plain text. It has this meta labels, meta tags, whatever. But it's like a static information. It's more or less it's dead. You write it and it doesn't affect your code. It's just done run. It's done once and it statically stays together with the code. It helps us affect the code. The language could be about requirements, because this language is about requirements, about organization of requirements. You can design a language for architectural constraints. You can design a language for really in-code constraints, where you explain in English what you expect in the code to see, and then the code lives its own life. But these requirements, these constraints, these concepts which you define in this meta language are enforced on the code. That, I think, is it could be a future of programming, I think. It could be something that programmers may see more and more. I demonstrated you how BDD works. Remember this behavior-driven development in the last lecture, where I demonstrated you how you can write in a simple text, and then the tool Cucumber turns your code into unit tests, into integration tests, and then to run the test. It's kind of in the same direction. So many things, many instructions to the computer we can give through normal English text these days, but not through the English text which is uncontrolled, but the controlled English text, the text which a user cannot write freely and use anything the user wants. For example, here I say where user identifies himself. I cannot say, for example, identifies them or identifies him. I can only say himself or herself. Just a few words are allowed here. Or, for example, here, timeline is a. I cannot say, like I said, maybe is a. I can only say is and a, because those are the tokens. So that's why it's called Controlled Natural Language, CNL. So think about that. This could be something you might use in your project. You might become an author of that. I don't think you will use something like that from other people, because every programmer would like to invent their own languages, their own, especially in this territory. But maybe something like that will become a status quo, will become popular in the market, and we will use more and more of that stuff, more and more languages like this. But now, because I created this, I don't know, maybe 6 years ago or 7 years ago, but it is stable, it works. You can check it on GitHub, works pretty well. You can use it in your project, but it's not a standard on the industry. It has maybe, 40 stars on GitHub, and that's it. So we don't have something. It's still academic. It's still in the research. It's still nothing popular.